Object-oriented programming is all about objects. An object is a black box, which receives and sends messages. A black box actually contains code, or sequences of computer instructions, and data, or information which the instructions operate on. Traditionally, code and data have been kept apart. For example, in the C language, units of code are called functions, while units of data are called structures. Functions and structures are not formally connected in C. A C function can operate on more than one type of structure, and more than one function can operate on the same structure. This isn't the case for object-oriented software. In object-oriented programming, code and data are merged into a single indivisible thing, an object. This has some big advantages, as you'll see in a moment. But first, a primary rule of object-oriented programming is this. As the user of an object, you should never need to peek inside the box. You may be asking, why shouldn't you need to look inside an object? Well, for one thing, all communication to it is done via messages. The object which a message is sent to is called the receiver of the message. Messages define the interface to the object. Everything an object can do is represented by its message interface. So you shouldn't have to know anything about what is in the black box in order to use it. And not looking inside the object's black box doesn't tempt you to directly modify that object. If you did, you would be tampering with the details of how the object works. Suppose the person who programmed the object in the first place decided later on to change some of these details. Then you would be in trouble. Your software would no longer work correctly. But so long as you just deal with objects as black boxes via their messages, the software is guaranteed to work. You also may be asking, why all this concern for being able to change software? Well, because experience has taught us that software changes. A popular adage is that software is not written, it is rewritten. And some of the costliest mistakes in computer history have come from software that breaks when someone tries to change it.
So, how are objects defined? An object is defined via its class, which determines everything about an object. Objects are individual instances of a class. For example, you may create an object called Pencil of the class SimplePencil. The purpose of SimplePencil is to manipulate another object, Paper, using both pencil and paper's message interfaces. I'm not directly changing either object. As you can see, within the pencil's black box, we have data, methods to create an instance of SimplePencil, and a lot of methods that define what we can do with SimplePencil. These methods comprise our pencil's message interface. We can use these to manipulate Paper. To further drive home the idea that you do not need to look inside the box, I will show you absolutely nothing about Paper. We will change it using only Pencil. For example, let's say I want to draw a line on paper using Pencil. All I need to do is use a few of Pencil's methods. When I show the paper, you see a thin black line, as you can see here. So what if we want a thicker line? We can use more of Pencil's methods. Let's say we want to change direction or even change the color of the pencil. All of this can be done without using Paper at all. All we need to do is use Pencil to send messages to Paper. In the end, the only thing I've done with Paper is use the show method, which just shows the results of the messages Pencil sends to Paper. As you can see, object-oriented programming offers a new and powerful model for writing computer software. Objects are black boxes which send and receive messages. This approach speeds the development of new programs and, if properly used, improves the maintenance, reusability, and modifiability of software.